Hi there, I'm Bethany Moats. Welcome to the Kامsól series of post-processing tutorials where we show you how to utilize the wide variety of post-processing tools that Kامsól Multiphysics has to offer. So to open the next model, we'll click View, Model Library, and then we'll navigate to the Acoustics module, Tutorial Models, and Gaussian Explosion. Clicking Open Model. This is a model that's symmetric about the x-axis and that tracks a Gaussian pulse of sound from one focus to the other over time. If we take a look at the 2D plot here of the acoustic pressure, you'll see that it's plotting only the actual geometry that was simulated, which is really only 1/2 of the full geometry. So in order to view the solution on the full ellipse, let's go ahead and define a mirror dataset. We right-click on Datasets and choose More Datasets, Mirror 2D, and we're taking our solution from Solution 1, which is correct. But now to define the axis we want here is the x-axis, so we need to change this to 0, 0, and 1, 0. Now we can go ahead and plot this dataset to be sure that we have correctly defined our ellipse. So now we can go back to our 2D plot group 1, and we can change the dataset to be coming from mirror 2D 1 instead. Now if we click plot, you'll see that we can see the entire solution on the full ellipse. Another tip here is to add a height expression to the surface plot to be able to best visualize the magnitudes at this point. But now if we go back to the settings window for the 2D plot group, you'll see that, as in the last model, we can only view this plot at one point in time. Sometimes it's helpful to be able to see instantaneously snapshots at different points in time. So one way you can do this is to create an extrusion dataset. So to do that, we'll right-click Datasets, choose More Datasets, Parametric Extrusion 2D. Now here's where I'm going to show you how to string together datasets. The default dataset here is Solution 1, but if you'll remember, Solution 1 is only half of the ellipse that we want to view. So now on this parametric extrusion dataset, we can actually take as our dataset the mirror 2D dataset that we just created. Now here we'll choose to show all of the different time selections available, and we'll choose our level scale factor to be about 2000, which defines the separation between the different levels you'll see. Now if we click plot, you'll get an idea of what these different levels are going to look like once we've graphed them. So now if we want to visualize the pressure over time on this dataset, we'll now want to go right-click on Results and add a 3D plot group this time. And you'll see the dataset has detected the parametric extrusion 2D dataset we just created, which is a 3D dataset once the 2D dataset has been extruded. And now we will right-click here, add a surface plot. And on these surfaces of the extruded geometries, we will plot the instantaneous pressure, the default here. And we'll change the color table to be the wave color table. And now we'll click plot. And now you'll see here in the graphics window a snapshot over time as the pressure is introduced, the Gaussian pulse is introduced, and over time how this wave is propagating to the second focus of this ellipse. Next, I will demonstrate how to display results on the full geometry once you've taken advantage of sector symmetry in your model. To demonstrate this, we will use a model of a Breuil and Kjær 4134 condenser microphone, which could be found in the model library, choosing View, Model Library, by going to Industrial Models and BK4134 microphone and choosing Open Model. This is a great example of a true multiphysics model, which involves thermoacoustics, membrane structural mechanics, and electrostatics modeling, along with the calculation of a moving mesh to achieve these results. Here we want to plot the deformation of the membrane plus a slice plot of the voltage on the full, complete geometry here. So in order to do that, we need to first create a sector dataset. We'll right-click on Datasets and choose More Datasets and Sector 3D. And then here we'll keep the dataset as Solution 1. We'll keep the axis data as being the z-axis, as you'll see here in the graphics window. That's correct. And then we'll choose our number of sectors to be 12. And we'll change the transformation to be rotation and reflection, and define the radial direction of the reflection plane to be in the negative y direction. This is because, as you'll see in the graphics window here, you'll notice the half circle, and so the line of symmetry of the reflection that needs to occur is in this direction, in the opposite direction of the positive y direction, which is the negative y direction. Now we'll create a 3D plot group. First, one that has a surface plot that shows the acoustic pressure and also shows the shape of the deformed membrane. So to do that, we need to right-click Surface, add a deformation. By default, we have the displacement field here as we wanted. But now you'll notice that this is only being plotted on the piece of the geometry that was actually simulated. So we need to go back and choose the sector 3D dataset for our plot group here. And now if we replot that, you'll see the pressure according to the color bar here. And you'll see the shape of the deformation on the completed geometry. Notice how there's both the reflectional symmetry as well as the sector symmetry here. And now maybe we want to add a slice plot throughout this volume to know the voltage throughout the device. So now we'll right-click on the 3D plot group and we'll add a slice plot. And we'll choose here electrostatics, electric, and electric potential here. Now we'll plot that. And now you can see slices through this sector dataset. Note that you can also change the color scheme of the slice plot if you'd like. As I said, you can create any plot on this dataset just as you would any other 3D dataset.